So hi everybody, welcome to this ULESCA webinar where we're going to tell you about how experienced security engineers choose their best tools for application security. I want to welcome you to this session. We're excited to have everybody with us. This session is going to be given by myself and my colleague Martin, and we're going to enjoy going through a couple of technical details as well as some case studies. So, just to introduce ourselves before we get into it, ULESCA, if you haven't heard of us before, we're a platform that helps organizations scale their application security, testing, and automation by automating and orchestrating the various security tools in their CI/CD or their pipelines. So essentially wrapping the different tools together, running them automatically in CI/CD pipelines, collecting the results together, helping with the triage and risk and communication, etc. To introduce myself, my name's Guy Robinson. I'm a founder and chief security officer at ULESCA. I've 20 years of experience in software and cybersecurity, including 15 years as a developer, stint at security architect over at Citigroup. I was a global board member at OWASP, and for the last number of years with ULESCA, we've been working to really focus in on how to do DevSecOps properly at the technical and the process level, and make it all work together so that everybody can save a lot of time when doing this really important act. With me is my colleague, Martin Hewitt. Martin, do you want to introduce yourself?
Sure, thanks Gary. Hey everyone, I'm Martin, I'm the Chief Product Officer at ULESCA. So my background's in security and engineering. I've worked in a number of different industries, and looking at how they all develop software is how we bring ULESCA and security into the development lifecycle of our customers, and that's what I'm going to be covering today.
Thanks, Martin. Thanks. So just to go over what we're going to cover today, we're going to talk about technical and case study. I'm going to cover the technical bit, talking about the landscape of various security tools, what is there out there, what categories are there, how do they work together, etc. And then we're going to cover three sort of focused aspects of security tools and how those aspects of AppSec tools make them fit or not into your desired security automation setup. So we'll cover regulations and standards of the tools, technical aspects, and more importantly, the cultural fit. Now, as well as the technical aspects, we'll weave in lots of stuff from Martin, who's going to cover much of a case study.
Yep, thanks, Gary. So the case study we're going to cover is an amalgamation of a few different customers. So that for that purpose, we've sort of grouped them all together and called it FutureBank. They are, for the purposes of kind of getting your sort of head straight in terms of their context, they are a fintech startup. They're 2 years old, so they're starting to scale. They are twin-homed in London and Berlin, so they've got quite an intersection of regulation to deal with. They have a security team, but it is hugely outnumbered by the engineering function, sort of the product feature delivery side of the organization. They've tried a couple of tools, mainly static tools, and they've experimented with a couple of dynamic projects, but their main drive over their security sort of AppSec program is to shorten how long it takes to find and to fix security vulnerabilities. They're currently found very late in their process, and they've got increasing compliance burdens to sort of satisfy around how they are covering the regulations that they're subject to and how they're improving that over time.
Thanks, Martin. Thanks. So this is going to be wrapped into this presentation. Imagine this is almost like one of those hair shampoo adverts where Martin's going to be the beautiful advert talking about how this relates to you, and I'm going to be the boring sciencey bit talking about the technicality. So what we're going to do is start off with that technicality about the landscape of security tools, because one of the more frequent questions we get when companies are coming to us either with our product or with our consulting services to understand more about how they can get this automation ramped up and going in their organization is what tools are out there, what types of tools are there, what's our landscape. And the landscape in application security or general security is quite broad. So, something like Kali Linux, which a lot of people know from pen testing, is a common operating system that you would use if you're going to do a pen testing exercise. That operating system alone has over 600, freemium or open source security tools that will be wrapped into the system. Now, apart from that, there's plenty of other commercial tools that you can use and plenty of other scripts out there on things like GitHub, GitLab, etc. And by the time you bring them together, you can have a choice of hundreds of different tools, from big commercial tools that do lots of things to very focused open source tools. And one of the questions can be what's most effective. And that's really something we're going to focus on here in this presentation. It's not about taking a tool and putting it in. It's about taking the right tools, and it's about ordering that the right number of tools as you grow your application security automation program to make sure you're getting the biggest bang from the buck, not just in terms of findings, but in terms of it working as it operating for all the different departments working together. So from Uleska's point of view, we kind of see 8 main categories of security tools that can be used in and around AppSec and other associated areas. And it really depends. And what we've done here is break them up into the areas of your pipeline or your release cycle that you might interact with some of these tools, just to give them a category. So in and around the code analysis, you'd have SAST and infrastructure as code checks. So SAST stands for Static Application Security Testing, which essentially is your tools which check the source code or binaries to find flaws and to be able to flag up issues like SQL injections or command injections, etc., that they can see. Infrastructure as code checks, they're slightly newer, but the ones that maybe check your Terraform, your CloudFormation, your Docker files, etc., to see if there's any known problems there with how that code is being used to set up your infrastructure. If we move over to the component side, really where we're bringing different things in together, probably from third parties, you have your SCA, your software composition analysis, which is commercial and open source tools that check the third-party libraries or dependencies you're using and basically matches them up to see is there any known problems with those, and an upgrade might be necessary. Same can be done with containers, looking at the images or the layers of your containers to see if there's any known flaws there. So whenever you're using these third-party dependencies, you can know you're using those securely without flaws coming in. Later on in your build environment, then when you get to the stage, the testing stage, you can wrap in your dynamic application security testing, your DAST, which essentially sends traffic to your running system in hope of finding responses that indicate that there's security flaws there they can report on. You can also have IAST, which is interactive application security testing, which acts kind of like a WAF and a SAST together to have a layer inside your program that can spot up flaws and relay them to you. And when you get to the CD, the deployment stage, then you have essentially your cloud and infrastructure checks, which are kind of the same thing, but depending on the way they're done. And basically that's going to check, is your S3 buckets lying open? What's your IAM looking on your cloud side? From the infrastructure point of view, what ports do you have open? What systems do you have running? Is there any patches needed in your operating systems as well? So that's the high level categories. And we see many security programs having to bring in different aspects or different tools from each of these categories to be able to build up that level of coverage to make sure when they're releasing daily that they have the coverage they need. So aside from the technical categories, from the sort of commercial, from the usage side, there's really 3 high-level categories we have described here, which is commercial, open source, and custom tools. So to start with the commercial tools, and just to go through the high-level pros and cons here, because with these categories of security tools, the ones we've covered before here, and the commercial, open source, etc., you can spend a whole 2-hour session on that, and we don't have time in this particular webinar, but we can come back later on to our website, or we've got many blogs which do describe some of these aspects. So for commercial tools, when you're wrapping those into your security automation programs, there's pros and cons. So the pros are generally these commercial tools tend to be wider range and they cover a lot more types of security controls, and they tend to have quite good UIs to be able to log false positives or generate a report or have that remediation text or description or even a training course to say here's how the developer can actually fix this, to sort of reduce that time to fix when these things are found. The cons typically of commercial tools is there's a cost to it. They're obviously a commercial entity. That means it may be more of a struggle for smaller companies to afford these tools, or for larger companies, even enterprises, to be able to utilize those commercial tools for all of their software development teams. That can be a choice of how much you can afford there, how many systems or teams you can use these commercial tools for. When it comes to open source and custom tools, essentially open source tools are the ones you can get from free from the likes of Kali, from OWASP. There's plenty of systems on Git, GitLab, etc., where you can download really good tools that can do a security check for you. And then there's also custom tools, and they tend to be the tools you'd actually write yourself. So it could be a 10-line Python script, or it could be something that Jamie or Janice developed in the operations team just to do a bit of a security check because it made sense to automate that and put it inside a script. Like, typically they are very custom to the way your software is, maybe checking how you authenticate, maybe something that's quite specific to the port you want open or not, or maybe something that's related to the business logic or the authorization of your particular product that just wouldn't make sense to be captured in an off-the-shelf tool. And when it comes to your open source and custom tools, generally they're quite good because they're quite niche. They're focused on a particular check you want to do. They're also free. So once their custom tools developed, or once you download the open source tool from the website, you can get it, you can try and use it, see what sort of issues it finds. It'd be quite good to try it out and see what you're going to get. And it comes to an automated security program, the disadvantages or the cons of a open source or custom tool is that there's generally less functionality for any user interface. They've usually got a bit of an API, or maybe they're exclusively called from the command line, and they wouldn't have any way to sort of log false positives or non-issues, etc. So it's a bit harder to be able to track issues across executions, but also bring issues together when you've got lots of tools running in one pipeline run. So that's kind of the landscape of security tools that we're going to deal with. There's lots of them. They can work in different areas of the code or different checks that we're looking for, and you can have the commercial and your open source custom tools. So taking that landscape of tools that are out there, how do we then determine which ones are the best fit for us as we roll out our security automation program? So typically in the past, you would have had penetration testing exercises, manual teams or outsourced companies that would run a lot of tests to check your system. And implicitly, that would have been assumed to cover the whole scope, the whole remit of different types of security controls that you can have. Those penetration testing exercises would still have had people that run automated tools as part of that exercise, but there also would have been a number of manual checks they would have done. And as we see close to the bottom here, that type of security testing mechanism is the long tail. You're going to do that every 6 or 12 months. So when you get to the position of move left, shift left, and the speed of DevOps automation we have now, with the releases going out daily, that does give us a gap in our security, because we're going to have releases that go live where we don't know the security situation right now. We might have to wait 5 months and 30 days until the next security test. And that is a risk in itself. Having the issues come out of tools, that is obviously a risk, but the bigger risk is not knowing about that. The analogy is the one thing more riskier than driving a car with no brakes is driving a car with no brakes where you don't know that. You don't know it doesn't have brakes. So this awareness, especially even on the daily releases, is quite important to have, and that's where this automated tooling approach can return dividends. So what security do we care about? If you're a mid-tier, if you're an enterprise, you'll obviously have your regulations and standards that you're conscious of, that you need to adhere to as a company. And even if you're a small startup or an SME, you'll still be selling into those companies, and they would have to be checking your software and your releases as well. So what we find is lots of companies have the various standards or regulations that need to check. And by taking those and bringing them together, you can actually sort out a list of controls that, down to the technical level, specify what you need to check for. So if you take something like NIST or OWASP, etc., you can actually get a list of a number of, like, couple of hundred controls that you would need to be checking for, either in your manual testing or in your automated testing. Standards such as OWASP ASVS itself lists nearly 400 controls that you could check for in an automated test. And what we find is when you bring those sort of things together and you have those lists of controls you need to check for, you can then take the tools, be them commercial, open source, or whatever, and understand the controls that they would check for, and simply use that to map up this tool will check for that control. We have that ticked, and we can move forward. So we'll show a few examples of this. Here we're going to take the OWASP ASVS as our controls metrics. And if we look at 163 of ASVS, it's talking about passwords and keys being replaceable. So if we then look at one of the tools we might want to use, let's say Bandit, which is a popular open source tool for Python, that has a number of documented controls. And we see here that it covers a number of hard-coded password checks. So we could then consider that from the controls we have, including 163 of ASVS, we have a tool called Bandit, which can cover those aspects, and we can consider that particular box to be ticked as a control we're going to check. And you can imagine, even as an Excel spreadsheet, you could have hundreds of these controls where you're going to have this mapping up to be done. If we take another example, 537 from the OWASP ASVS, which talks about things like LDAP injections, we can then look at another tool, SonarCube, which is a very popular freemium and commercial tool for scanning different types of codes. And we can see it's got controls published which check for LDAP queries being injected. And so that's another type of control we can do, and we can consider we then have ticked. And as you can see at the end of that, what you would have is you would have all your controls listed, and you'd be growing the number of tools that you could have in the check and see where they're giving you controls, where they're giving you the coverage. And that leads you to a situation like this, where your tools will give you in a daily change or every change scenario, the types of controls you're going to have covered. And you have visibility and awareness that that's something you can then relate to your customers or to your auditors, etc. We have that happening whenever we do these daily releases. Now, there will be gaps, and those gaps, again, can be specified by manual testing, which will happen every 6 months or whatever that's going to be. And what you can then start doing is a bit of a feedback loop, which, again, lots of regulators love, where you can start saying, well, in our manual testing or in our bug bounties or whatever other mechanisms we have, when you start seeing the same sort of categories of issues coming up that you don't have covered in your automated tooling, you can then start adding in new custom tools and new open source tools, etc., whatever that's going to be, that would start plugging those gaps. And so you have this feedback loop that informs the risk of the various controls you want to check against and increases that automation layer to be able to qualify that as you're doing your daily checks. So I'll let Martin talk about the way this works in one of our case studies.
Thanks, Gary. So as Gary just discussed, FutureBank are starting down this mapping process. They went with ASVS as their set of controls to normalize everything down to, but they're not going to try and tackle them all at once. As Gary said, there's hundreds of controls in there. So from a security team perspective, they started small, working purely with some controls they had a ready hand on. To have peace of mind as a security team, to become comfortable with the controls, how they, and kind of get comfortable with that mapping process. So they started with internal applications, allowed them to, again, bring the scope of the project, this first mapping project, down and to iron out the process kinks before pushing it wider. They were looking at how can they start to onboard those internal applications, how can they start to get that coverage, and how can they start to link any vulnerabilities that they find back to their control list.
Thanks, Martin. And just to mention at this stage, we will have polls in the live storm event if you want to answer any of the questions in the polls. There's also an opportunity there to ask questions of us. So we'll get to the questions at the end of this session. There will be time for that. But if you do have any questions, please log them in there and we can get to them at the end. So to move on to the next technical aspect of how we would choose what tools are going to go in, it is technical aspects. Essentially, there are some elements of how your company will be set up that will determine and actually rule out a bunch of tools that just wouldn't be suitable. To look on the right-hand side here, first of all, that tends to come down to whether your security checks have to be run internally, inside your firewall, or whether they can be run in the cloud. We see between customers around about a 50-50 split of companies that still just with their regulations have to keep things in-house, and so any security tooling or any security checks would have to be run inside. Maybe the code's not in the cloud yet, that sort of stuff. And so if you have tools that only run on the cloud, then that's essentially going to rule that out. That's quite an easy way to decide on some of the mechanisms that can be used. Moving over to the left-hand side here, this can generally be a lot more fluid. And it's down to the technicality, which means the languages or the platforms, etc., that your development teams are using to develop the software. So what do we mean here? We mean if your development teams are running in C# on Azure DevOps and running to the Azure cloud, well, then there's absolutely no point in running a script or a tool that's going to check your AWS cloud, because that's just not applicable to you. Same thing for the languages, especially when you get to open source, they tend to be a bit more specific. So an open source tool that checks for Python or checks for Ruby or Go is just not going to be an option for yourself right now. So part of the exercise here is to understand, well, what is our landscape as a client? What is the number of languages we use? There's never just one. There's always, front end, back end, different languages. We also see lots of different teams that have that use many languages across teams. So you might have a group or a bunch of teams who work in one language and another group that works in a different language. Or you might have development teams that want to start or have the freedom to start using Rust or Go or whatever that may be. Or we've seen it where a company is purchased and there's amalgamation and suddenly there's a whole other development organization which is used to work in completely different languages. And here, part of the lesson is to make sure that your security program, especially the automation parts of your security program, are built around the program or the procedures you want to do and not specific to the tools. We have seen organizations that have been so ingrained in the tools that they can't really change from one vendor to another because it would change the way their whole program works. So it's best to be independent of that and be able to say, well, we have our security program, we know what way we want to report and measure the security checks we're doing automatically, and we slot in the various tools that match the languages as we need. And this then means whenever a new team wants to start using a new language or whenever something else comes in, you can slot those new tools in and still keep with the same reporting and operation mechanism without redefining and redesigning everything. So this one thing to keep in mind, a bit more on the commercial side of the tools, is there's really a suck it and see aspect to this. Every organization wants to do the best in terms of the checks they can do, but there will be a difference. There'll be a difference in quality between the different languages inside an organization. So we've seen vendors that are very good on one language, maybe struggle a bit more on a different language. So for yourselves, depending on how you use the language, which languages you're using, it can be worthwhile to do trials and check out different vendors to see what finds the best results for you. And we do mean best results, not the most results, but the most accurate, maybe the least false positives, that sort of way of fitting in with how you use the system. So again, Martin will move to the case study.
Thanks, Gary. So this is FutureBank starting to run their first tests and onboard their first applications. So kind of working from the bottom up, looking for quick results. So they started by mapping the most readily addressable controls according to the tools that they had experience with. They experimented with a few different tools. Some were off the shelf, some were open source, some were commercial, and some were better or worse fits for their organization or for their staging environments. They needed some customizations to one of their tools. For our platform, this is just a question of wrapping it in a Docker container, but there's that kind of that fit that Gary was referring to. Once they'd found that sweet spot of tools and controls, then it was a question of which tools are going to work properly in our environment. Which can reach through a firewall, which can communicate with the right environments in the right place. So looking at the sort of the coverage they were looking for, you can see here how we go about kind of building up a coverage of those controls over different phases of that life cycle. So we've got, if they just use Bandit, they would have covered 16 controls. Adding in SonarQube gets you another 30 odd, and then finally running some dynamic testing where appropriate gets you a decent leg up. So by the time you've got those fairly straightforward open source tools all integrated, you've got a decent coverage of 87 controls, and that was what they decided was good enough for their initial pilot for their internal projects that they wanted to kind of to start to build the process and improve the mapping. But it was important to them to make sure that the tests that were being run and the checks that were being run were appropriate to where the risk was being introduced. So not doing dynamic testing every time a pull request was merged, but also to make sure that where those tests are being run, then over time it builds up to cover what's needed by the time you have an operational application.
Thanks, Martin. So to the last aspect of determining the fit of these tools, it is down now to the cultural fit, and that's very, very important. There's lots of technical aspects you can do here, but if you get to a point where you have a group of automated tools, and that's always going to grow. Just for reference, we have seen organizations, start 3, 5 tools, whatever, but we've also seen organizations on the larger side which are regularly running hundreds of tools, combination of commercial, open source, and a whole lot of custom tools as well. And so this really has to work for everybody in the organization, especially the teams who are working in this area. This is a nexus of development, security teams, and the operation teams. And if developers are getting loaded with lots of issues they don't think are real and the wrong things being tested, if the security department is spending too much time trying to maintain this and answer all the questions but aren't getting the return on investment, and if the operations teams are having their CI/CD platforms ripped apart with all this random security code, it can definitely be a problem if you're not getting, let's just say, that return on investment and the outputs you want from the security checks. So cultural fits are very important. And what we're going to look at here is a couple of aspects of how to make sure that works for the surrounding departments as well. Because at the end of the day, this is all about risk. If you look at the language of many of the regulations, from PCI DSS to the New York CRR to BaFin and others, you'll see that the language is not about find vulnerabilities, it is understand the risk. So I have an SQL injection, that's a vulnerability. But is that SQL injection going to just be affecting an internal system with no sensitive data and nobody really using it? Well, that's low risk. Or is the same SQL injection going to affect millions of financial records in an external system that's public to the internet? That's then a big risk, or the talk hack. So it's all about understanding the nature of these, and that means then a bit more wraparound of the application context as well as the vulnerabilities themselves. But what we've also seen is the risk conversation can also help generally those internal conversations. It helps make the case for security. When we're in those sprint meetings and you say, well, we have to fix this XSS vulnerability, the technicality of that may not be understood, especially not understood by project managers or stakeholders as much as a feature or as much as the business case of some of the other aspects they want to bring in. But if you're able to say, look, this is a $30 million risk, or this is the same thing that affected BA or whatever, you can then have that context to say, here's a better reason for us to have that conversation in the sprint meetings and have more issues go in. And it's also a way of getting better granularity on your prioritizations. Many of us have seen companies with tens of thousands of issues on their security backlog. And even if you get to the critical ones, you're still talking about hundreds, if not thousands. So how do you make sure you're working on the top ones that actually need to get burnt down? Again, using some of these risk methodologies. Uleska, we use FAIR automatically, but other methodologies are out there. Essentially, they give you more granularity. So you can say, here, the top one is a certain dollar value, which is going to be just simply as a number, the highest, and you can work down. And that then both brings in the application context. So not all your SQL injections are suddenly the same. You have that context, but also you'll be able to bring down and and show to the auditors and other companies that you're burning down the biggest risks as you are bringing down these issues. Also, just to mention about the sort of regulators and auditors side of thing, in the world where you are talking with controls and auditors, it does need to be proven. You would have procedures and you would have evidence, and it only exists if you're able to show the evidence that you have done something. And this is one of the aspects of shift left, where if more things are moving towards the development side, and say Jamie or Janice is throwing up OWASP ZAP and running a test every once in a while just to do a check, well, the added weight on that is that you need to have that recorded. You need to show that was happening, and you also need to have the evidence of that, which is your system of record. Now that can then, you can try and build that into your CI/CD or other mechanisms, but it is one of the reasons why Uleska captures that by rote, by automatic, because being able to have those security tests done, to be able to prove they were done, show the difference in testing, and have that not add extra jobs or weight either onto the development teams or the operations or security teams is really important, just to make sure those things are done. Because as we'll see later on, the cost of doing some of those tasks can actually reduce our ability to do the auditing and security of the software. There's also an aspect of separation of duties, which again comes into many regulations, which at a high level essentially says developers who write the code cannot be responsible for the security and the triaging of those issues. So automation thankfully brings in a bit of that separation, because the developers are not running the automation. Another platform or your CI/CD is doing that. But also then in terms of the triaging of those issues, you can't have, you can cooperate in that instead of one organization just setting everything as false positive, because that's an easier way to work. So what we've done at Alaska is try over the past while different ways to come up with a chart or an algorithm, whatever, to describe the best way to choose your security tools. And what we've come up with so far is this, and this may change in the future. We'll be happy to talk with anybody about this. But essentially, when you're taking your controls and you're looking at the various security tools, we apply this algorithm which says, well, first of all, if it's not a technical fit or it's not an environment fit, so if it only works in the cloud and the client can only work internally, or if it doesn't match the language, doesn't match the platform, doesn't match the cloud, etc., well, that simply rules those tools out. Now, obviously, that can change. There'll be a big shift if you move to allowing cloud tools, but also whenever you start moving to another cloud platform or start introducing other languages and platforms, suddenly these then mix in, and you've got to look back at that technical fit question. But assuming you have that level covered, for each individual tool, essentially what you can do is take the coverage that tool does. So does that cover 15, 20 controls in your list? Does it cover one control in your list? What does that look like? And what is the risk to you of those controls? So as Martin mentioned earlier on, there might be certain aspects of controls you're very worried about. It might be SQL injections, authentication. They're very, very important to us, either because of our company or because they're part of the regulations, or we have seen a competitor be breached in that way, or we've seen some of our risk analysis, maybe our SIEM are reporting a lot of a certain type of traffic. And so taking that coverage that the tool can do and the risk together, and then dividing that by the cost, can give you an element of the fit. Because if the cost is far, far too much, it just doesn't become something you can do. If the cost is lower and you have good coverage, that makes a lot of sense. And just to note that the cost is not just the license or the price of a commercial tool. Obviously, that's a factor. But commercial tools, as well as open source and your custom tools, they'll have a cost to how much time it takes you to run it, how much time it takes you to bring the information back and maybe bring it all together. We know of organizations that have somebody working for 8 or 9 days a month just to go around the various tools, bring all the information back into a spreadsheet, triage, work out what's different, and then start a report on that. That's a cost to using these tools. Same thing if it's loading in lots of false positives to the development team or causing the security team a lot of extra work to try and describe to the development teams how to apply these fixes if the remediation descriptions aren't that good. So just to show a few examples of using this type of algorithm, let's take an example of Bandit. Here we've got an organization that just doesn't code in Python. Therefore, from a point of view of technical fit, it's not going to match. That's an easy one to put to the side. And keep in mind, if we ever start using Python, maybe one we need to bring in, but not for now. If you then take a popular tool, we're big fans of OWASP ZAP. Assuming it's a technical and environment fit, you can then look at the controls, because if you take just something like OWASP ASVS, OWASP ZAP's a good match for around about 46 of those controls. And assuming those controls are things like SQL injection and other sort of authorization and security headers that you're interested in, that means they're high priority for you. And then if you take the cost of actually using OWASP ZAP, obviously it's a free tool. They give good examples of Dockers and stuff that you can use as well. Although there is then a use to sort of get the setup, get the authentication going, get the outputs of that there and bring it together with everything else. So there is a bit of a cost to using it. But that can then mean it's quite a good fit. And we find a lot of companies use tools like OWASP ZAP and the similar, because they've got a wide range of controls, but they're also affordable in terms of cost and time. And just one other last example of a commercial, say, static analysis tool. Assuming again, you've got a technical and environment fit, say a good range of controls, something like 65 or whatever controls would be covered, and they're maybe high priority to you. Then what you can do is say, right, well, do we have the budget? Do we have 100K to buy the licenses for this? Do we have that in our budgets section? And what's the usage of that? You know, does it have a good API? What does it cost us to try and analyze all the results? And this is actually one of the reasons why Uleska spends a lot of time to try and break down the usage and the amount of actions you need to do, because that really relates to the cost. You know, Uleska automatically spins up the tools and runs them. Uleska brings all the different results together. It triages the issue. It does the risk prioritization of the issue. It makes it really easy to spot. You had 50 issues before, now you've got 52. What are those 2 new issues? It can help communicate with Jira and other things they got there. Because a lot of those costs of actually using the system, whether it's commercial or whether it's open source custom, if they're limiting your ability to actually bring those tools and that coverage then into your automated procedures, that's not good for the industry. That's not the way we're going. So that's why we bring down a lot of these costs. So just to relate that then over to the case study with Martin. Martin, go ahead.
Thanks, Gary. So yeah, so this is FutureBank starting to socialize their new approach to application security throughout the rest of their organization. So because they've started small, you know, they've run a few applications through regular testing. They've integrated it into the different build stages of those applications lifecycle. The outputs that they've got from our platform mean that they've got these quantifiable risks. So this is more than a high, medium, low. This is the FAIR algorithm that Gary mentioned. So it takes into account the CVSS sort of score of those vulnerabilities, but also overlays market and business context onto it. Now, because they've got these kind of very fine-grained risk calculations against each of these vulnerabilities, the discussions they're having about what to work on now, what to triage, how to prioritize their development, and also what constitutes, you know, issues around compliance are much more concrete. You know, they've got these examples of discovered vulnerabilities. They've got all the information they need to kind of go to the different stakeholders in the security sort of landscape and say, this is what we found. These are the types of things that we'll start to bring up more of when we turn this process and we bring it to bear on external applications. This is, you know, let's start working through this now, and that allows them to have this security backlog. So because the platform is the thing doing the testing, it's the first often to see an issue, and it's the first to validate that it's been resolved. So to that system of record point that Gary mentioned a few moments ago, this backlog is the definitive list of the current risk presented by the applications that have been enrolled in it. And that's a very powerful kind of single pane of glass, in the sense that you can easily see how you're making progress to burn that down and whether that's getting bigger faster than it's being reduced. And that's where they get to these new business metrics that help report on what it is that their AppSec program is kind of what change that's bringing. Reporting on time to fix, again, because we're the first to see it and the first to validate that it's been resolved, we can report on that with solid granularity. Issues found, so integration with the software development lifecycle, you know, putting those kind of crocodile clips on different parts of that process allows to instrument it at different places. And then finally reporting on the control coverage. And that's how they start to up their tool coverage and how they start to negotiate around what's the highest priority to source a cover for a particular ASVS control from. So moving on to kind of once they've got these first few internal applications, the next step is to sort of point that outward. So starting to really bring this process to bear on the applications and the software that faces the kind of the rest of the world. Now, because they've already gone through this process with the internal applications, the reporting process is already well understood. The way the risk amounts are calculated is already understood. The way the vulnerabilities are presented already understood. But because the FAIR algorithm takes into account whether a system is internal or external, also takes into account the number of users that access that system. The risk levels have jumped up a bit, but because the underlying processes are the same, then there's that discussion that can happen with those rather more concrete kind of prioritization inputs. Using the same controls as with the internal applications. So they're using the same tools that they've tuned, they're using the same tools that they understand, they can do the same mapping process to understand what controls and what kind of compliance coverage they're giving to those external applications. And then the next step is simply iterating to onboard more applications and broaden the scope of the program. So the wider sort of rollout starts in the kind of bottom right corner of this, where they take the tools that they've already deployed and bring them to bear on more applications in their estate. So that could be enrolling them via the CI system, that could be enrolling them purely via config, but bringing them in to the Uleska platform so that they can be examined and calculated. Through that process, are evaluating the alert volume and the false positive rate to see if those tools are tuned correctly or not. They're reporting, so almost continual reporting on the time to fix, the increase and the decrease rates, and how those tools are covering the controls, particularly as they onboard applications that might be built on different libraries, on different frameworks, or even in different languages. How do they continue to maintain that coverage? And that's kind of where we start to look at how do they evaluate new tools. So if we have something that's very highly geared towards Python, but need to onboard a bunch of Java applications, how do we go through that mapping process again to make sure that those tools are still valid? How do we make sure that when we bring in those tools in a CI flow, the Uleska platform means that they can run it in non-blocking mode, in kind of listening mode. So you can put those crocodile clips on the development lifecycle, see what kind of issues are being found, but you don't block the build just yet until you've kind of tuned them or got them to a place where you're happy. Then, once you've validated those changes and you're happy with, say, a 30% increase in risk threshold for stopping a build, then that's when you can roll it out more widely. You can turn that CI step into blocking mode, and you're suddenly in a much more robust place. So this sort of infinity loop is really that process of how do you onboard more applications or keep pace with how those applications are being onboarded. You onboard them onto a standard known set of tools and controls and understand how that's being covered. But in the background, decoupled from the engineering flow, you're also looking at evaluating new tools, making sure the coverage is where it needs to be, and kind of you've got your head up looking ahead. So that's kind of decoupling and letting that security team do what they do best, whilst also allowing the engineering function and the security checking to keep up with the scale.
Thanks, Martin. So we really appreciate you spending this time with us to discuss how certain companies and how we advise companies to look at the automation and the tools that they're going to use. Now, Uleska, we do provide this as a service. We're also looking on a roadmap to have this as part of a product. But what we wanted to do is be able to share some of the high-level thought processes and what we've seen work for companies, because you do have that situation where some companies think they have a certain level of coverage because they're choosing 2 or 3 tools that they like or they prefer or they've used before. But having that joined up thinking of understanding the controls to the tools technicality to what actually works as a culture for your organization is really important, both to the actual effectiveness of your security automation, but also to the culture. How does this work? How do people buy in? How do the developers want to use this here? How do they ask you to add more tools? And how do the security teams have a lot more information and control, as well as metrics to be able to report up? If you're interested in some of the risk aspects there that Martin mentioned in terms of being able to spot during the pipeline if you've got a 30% increase in risk, etc., you can view our last webinar, which covers how we do this here and gives a few examples and a few demos of how that can be done with the Uleska product to be able to automatically have that happen inside your various pipelines. For more information on this that we've covered here, such as the types of tools and more blogs, etc., you can visit us on uleska.com, where we have lots of blogs, lots of documentation, etc. You can sign up for a free account at the Uleska system to be able to try it out, have a bit of a sandbox, have a play around, to understand how that works. And there's plenty of DevSecOps tips there as well. You can reach out to us on LinkedIn and Twitter with Uleska Sec. And also you can say hello to us at any time with hello@uleska.com. So with that, we'll now move to any questions that have come up. We have ran slightly over, so apologies for that. But what we'll do is we'll check out any of the questions that have come up. So what we have is, we've got ability to do the, so something from Raquel, how many tools are too many? That's a question I don't think the industry has right now. I think that once you have a mechanism or a platform or a procedure or a culture where you can easily slot in tools to the existing process and the existing technicality, that it then gets to the point the number of tools actually doesn't really make a difference. Obviously, what you don't want is too many results or false positives or duplicates coming back to the development team, because that will be one of the first things that will destroy your DevSecOps program. But platforms like Uleska and others, and there's other ways you could set up your tools themselves with profiles to try and reduce the number of false positives, or try and track those so that they don't keep coming up. This is one of the things I mentioned at the start. Commercial tools tend to have the ability to mark a false positive and say, you're going to do a scan again, don't raise that up. But when you're using lots of the open source tools, and especially custom scripts, etc., they tend not to have that functionality to mark false positives. And the next time you do a scan, it's still going to report the same information back, because as far as the tool's concerned, the same trigger is there. That's why a layer above that, like Uleska, can mark those false positives, duplicates, non-issues. And even though the tools are still reporting those in, they're automatically sort of blanked out at that point, allowing the main issues, the actual backlog to come back, as well as any brand new issues, so they can be triaged at that point as well. If you had to recommend one tool, which one would it be? I'm not going to mention any of the commercial ones, because that would be a risk, because we're partners with lots of different commercial tools and they're all very good. We are, with my OWASP hat on, I am a big fan of OWASP ZAP. Simon Bennett and the team there have built a very, very good dynamic analysis tool that has a good record of finding good things. No tool is perfect, but it's able, in my experience, has been able to find a lot of things. There's also credit to a lot of the emerging cloud tool scripts. So if you Google around, or if you ask us, we could point you to them. There's lists of hundreds of different AWS or Google or Azure scripts that can check for various aspects. And if you bring those together, they can be a very comprehensive check of your cloud environment during the CD process, which can really help you. So at that point, I understand we have run over. Thank you very much again for your time for viewing this presentation. If you have any questions, as I mentioned, reach out to us at hello@uleska.com. And please check out our website and sign up for a free account if you want to. It's free, it's low cost, it's low carbon, it's a diet DevSecOps, so it's all fun. And if you have any questions about anything here or anything around the terms of DevSecOps, please reach out to Martin and I, and we'll get back to you. Thank you very much.